So we're going to go through Pythagoras and Trigonometry to try and give you some practice, guys. So we've got a question here. We ask the what do we know? Well, we know it's about a right angle triangle. We know it's got lengths in it. So we're thinking about Pythagoras trigonometry, and because it's got two lengths, it's asking us for a third length. It's going to be Pythagoras. The recommendation, as always, is write down the rule. So we recognise that we should have a picture of a right angle triangle in mind, labelled ABC, where C is always the longest side, the hypotenuse of the triangle, and the rule says that the length of A squared plus the length of B squared is equal to the length of C squared. So now we kind of know that's the rule we're going to be using for this question. Then we can label up and decide what we need. Well, we need to get the side of C, so we're going to write down 1.2 squared plus 3 squared equals the length of C squared, and then we get 1.2 squared is 1.44, 3 squared is 9, that's going to be C squared, and then we're going to say that C squared is equal to these two added, so 10.44, and then C is going to equal the square root of 10.44. So okay, so 3.23. Okay, three significant figures. So if you remember, we count from the first non-zero digit, 1, 2, 3. The fourth significant figure doesn't change the one before because it's less than 5, it's less than halfway up. So this becomes 3.23. The next question talks about another right angle triangle, and again it's got two lengths. It's asking us for a third length, so again it's shouting out at us to use Pythagoras rather than trigonometry. So we go through the process again, write the formula, recognise C is always the longest side, write the rule down, the length of A squared plus the length of B squared equals the length of C squared, and then fill in our numbers. So we've got 6 squared, because we've labelled up A, B and C. So we've got 6 squared plus 2.5 squared equals C squared. So we've got 36 plus 6.25 equals C squared. So C squared is equal to 42.25, and the opposite of squaring is always doing the square root. So the length of C is going to be the square root of 42.25. Again, square root 42.25 equals 6.5 exactly. This next question says the right angle triangle has sides shown. It wants you to show that x is equal to 9. So these show that questions kind of imply something more complicated than what it really is. It's always about recognising the topic area, what formula you're going to use, and then plug in things that they tell you to give you what they want you to show. So we've got here another right angle triangle, we've got two lengths. They're asking us to find the third length to show that it's 9, and really this is a case again of recognising this is about Pythagoras. So we go through the process of labelling once we've written the formula out so that we recognise what we're doing. So A, B, C, C being the longest side always. So the length of A squared plus the length of B squared equals the length of C squared. And we then go through the process of labelling the triangle up. So let's call that side A, side B, side C. So A gets replaced with x, so that's going to be x squared. So x squared plus 40 squared is going to equal 41 squared. So we want to make x the subject because we're asking to show that x is equal to 9. So move everything to the other side, away from the x. So the opposite of that is take away 40 squared. So we're going to take away 40 squared from there. So we've got x squared is equal to 41 squared minus 40 squared. So x squared is equal to, so we've got 41 squared minus 40 squared equals 81. So x squared is equal to 81, and x is equal to the square root of 81, which equals 9 centimetres. So that's all the show that I really wanted you to do, is start with the correct formula, a squared plus b squared equals c squared, right angle triangle, two lengths given, need a third length, Pythagoras. So write his rule down, and then plug in the numbers that were given in the question, rearrange it, and we find that we get the 9 out. Now this next question looks as if it's quite complicated, but again it really does come down to recognising what do we know. We know that this is about a right angle triangle, we know it's about lengths of the triangle, and therefore we're thinking of using Pythagoras. So again, start off by writing the rule down. So ABC, length of a squared plus length of b squared equals length of c squared. And really, when it says prove, it's asking us to replace these ABCs with what we're told in the question. So again, we'll go through the process of labelling the triangle. So these are the sides we're going to use. So we start with the rule, and the proof is literally to write out what we've got. So we've got m squared plus n squared equals n plus 1 squared. Now because there's two terms in there, then we're going to write out n plus 1 in a bracket squared to remember it's all of this that's squared. Then we need to realise that n plus 1 squared means you're doing the bracket times itself, so that's bracket times bracket, and then we need to do our usual multiplication of two brackets either through the grid or whichever method you prefer. So we're going to get n times n squared, we've got 1 times n and another 1 times n, so that'll give us 2 n's altogether, and then we've got 1 times 1, which is 1. So far then we've got m squared plus n squared equals n squared plus 2n plus 1. Rearrange this because the question says prove that m must be an odd number, so we need to make m the subject, so that's what that's telling us, is make m the subject. So we need to get m on its own, so we go through the process of recognising that we take away n squared from both sides, so that gives me m squared equals 2n plus 1. So we're proving that m must be an odd number. Well, m squared is equal to 2n plus 1, and what we should realise is the general rule of all odd numbers is 2n plus 1. We need to remember where that came from. So if we look at the odd number sequence, 1, 3, 5, 7 and so on, so it goes up in twos, this sequence of odd numbers. That tells me we're dealing with a 2 times table, and then when we write out the 2 times table, then we realise that we're 1 more than what we wanted, or we've got to add 1 to get this. So 2n plus 1 is going to be the odd number sequence. 2n is the even number sequence, add 1 to it, and you're always doing an even plus 1, and that equals an odd. Because m squared is equal to an odd number, m is the square root of 2n plus 1. So therefore we're recognising that m an odd number times an odd number is the only way you're going to create an odd number. So odd times odd equals odd. So 3 times 7 equals 21, 7 times 11 equals 77. So because we've got this rule that odd times odd gives us odd, then this is showing, it shows that m squared is equal to odd, therefore m equals odd number. So that's basically the idea behind the proof, that we're trying to get to the stage where we're recognising that m squared is the only way we're going to create an odd answer if m is odd. Because if m was even, if m is an even number, then m squared equals even. Well, that's not happened, so therefore m must be odd. Okay, so that's the proof of that particular bit. Then we come to the next question, and it's talking about two triangles, and we've got to say which of these triangles does a squared plus b squared equals c squared hold. Well, we should be saying something like a squared plus b squared equals c squared is Pythagoras' theorem, and only holds for right-angled triangles. So that means basically we need to work out the missing angles in these triangles. So basically we've got to say that the missing angle in triangle P is, well, we know that this angle here is going to be 180 degrees minus 58 degrees minus 32 degrees. Well, 50, 80, 90, so that's going to equal 90 degrees. So this is a right angle, and in this triangle the missing angle is going to be 180 degrees minus 44 degrees minus 36 degrees. 44 plus 36 is 80 degrees, so that equals 100 degrees. So missing angle in triangle P is 90 degrees, therefore Pythagoras will hold, as this is a right-angled triangle. So basically that's what that question's about. It's about proving that the angle is 90 degrees in one of the triangles, therefore you've got a right-angled triangle, and therefore Pythagoras will hold. This next question is asking us to work with the right-angled triangle again. So we're kind of thinking it's about lengths and angles, so it could be Pythagoras, it could be trigonometry, but as soon as we mention the fact that it's about angles as well, then we're talking about the use of trigonometry. There's lots of ways of doing this. There's the Sine Rule and the SOHCAHTOA approach. So we'll go through the SOHCAHTOA approach using the sine function, the cosine function, and the tangent function. So we label the triangle up. So there's the angle, so this will be the opposite side. There's the angle, this will be the adjacent side, adjacent being next to. And the longest side of a right angle triangle is always known as the hypotenuse h. So the usual thing, guys, we go through identifying what we know. So we know O, so we can tick under the word O. Therefore that one can't be used because already we don't know enough about it. The question wants the length of the hypotenuse, so we've basically ticked this one twice, so this is the function we are going to use. That means we write out what the function is, so we're saying the sine of the angle theta, so we've got to remember that this is the angle theta. The sine of the angle is equal to the opposite length divided by the hypotenuse length. So once we've written the rule down, then we can fill in the known numbers. So they've told us in the question we're dealing with a sine of 33 degrees because the angle is 33. We're told the opposite length is 125 meters and we need the length of h. So this is the subject, so we need to move this around to make h the subject. This says divide, so we're going to times both sides by h first, so that gives me h times the sine of 33 degrees. And that equals a length of 125 meters. We want h, so this is times, so we're going to do the opposite to move it. So divide by the sine of 33 degrees. Do that to both sides, of course, to make it fair. So h is equal to 125 divided by the sine of 33 degrees. And it wants an appropriate degree of accuracy, so we're going to round our answer to 3 significant figures. So let's go through. So we're saying 125 divided by the sine of 33 degrees. Notice we always make sure our calculator's working in degrees mode. So you'll either see the letters deg for short for degrees or the letter D there. So make sure you're seeing that in your window of your calculator so that you know you're working in that degrees mode. Equals, so 229.5. So for a suitable degree of accuracy, 3 significant figures. We would, so this is equal to 229.5098073. Always write down the full answer off your calculator before you do any rounding. And to 3 significant figures, this is going to be, well, the first non-zero digit is 2. So the first, second, third significant figure. The fourth one is 5 or more, so it's more than halfway up for the previous one. So that's going to make this a 10, which means that I'll put 0, carry the 1, so 230. So it's going to be 230 and again always give the units, so 230 meters. Okay, so this next question, it says the diagram shows two right angled triangles. So again, we know that we should be thinking Pythagoras trigonometry may be involved here, particularly as we see in lengths. It then talks about the cosine function, so that brings in the fact that it's involving an angle. So we're going to trigonometry, and it's asking us to find the value of the sine of y. Now this looks like it's going to be a non-calculated question because they've told us what the cos of x is. So therefore they're not expecting us to press a calculator button, and they're not expecting us to do inverse sine here, because they're literally just saying what is the sine of y. So in other words, what is the sine of the angle. So we just got to think through what we need. Now to get the sine of y, this right angle triangle would be labelled O, H, y's there, so this would be O, sorry guys. So the opposite side there would be O. This would still be H because it is the hypotenuse opposite the right angle, and this would be labelled A. We want the sine of y, so therefore we need the opposite length and we need the hypotenuse length here, because that will then allow us to use the sine function. So again, we've got to remember SOHCAHTOA. So we want to use the sine function because that's what they want. So that's what we know. We know we need to use this triangle to get y, and we know we need that length and that length to get the sine of it, O and H. So then we go to the other triangle because we need to find these values, and at the moment we know nothing about them. So can we get H? Well, when we look at the next triangle, we can see that this involves this x, and they're telling us what the cos of x is. So it's kind of crying out to us that this triangle, so if we draw it out separately so we can see what's going on, there's x, so this will be the adjacent side, this will be the opposite side, and this will be the hypotenuse. And because we want this side, and we know this side is equal to 40 centimeters, then we can go through the process now of recognising that the cosine function of x is going to be the adjacent length equal to the divided by the hypotenuse length. Well, they've told us what the cos of x is. They've told us it's 5/8. Told us that in the information. So again, it's about identifying key information. And we don't know the length of a, but we do know the length of h. We're told it's 40. So again, it's non-calculator, so they're expecting you to move the 40 across the other side by timesing. So we're saying that a is equal to 40 times 5/8. Well, this is a fraction question, so turn the 40 into a fraction, 40 over 1. So this is going to be 40 times 5, 1 times 8, 200 divided by 8. Well, we go through the process of divide by 8 is the same as halving, halving and halving again. So we halve 100, half 200 is 100, halve 100 is 50, halve 50 is 25. So there are 8 25s. So that means we now know, and when we know something, we add it onto the picture. So we now know the length of this is 25. Well, the question wanted us to work with this number here, and this number here. It wants the sine, so we need to work out that. Well, if we draw that triangle out separately, then we could see that that is y, opposite length, adjacent length, hypotenuse. Now for this triangle, we know that that's 25 centimeters. We know that this is 7 centimeters, and the question wants us to work with O because we need the sine function. So the sine of y is the opposite length divided by the hypotenuse. So we have to go through the process now of finding the length of O. Well, we've got a right angle triangle with two lengths known. So that's going to be 7 squared, because we're doing the Pythagoras of a squared plus b squared equals c squared. So we've got 7 squared plus o squared equals 25 squared. So o squared is equal to 625 minus 49. 625 minus 49, so take away 50 is 575. So it's going to be 576, so that's what O squared is. And O squared, so O will be equal to the square root of 576. Okay. So the square root of 576. 24. Okay, so we now know that the length of O is 24. So from our sine function, the sine of y is equal to the opposite length divided by the hypotenuse length. So for this triangle, we've worked out that this length is 24. So 24 over 25. So we're going to say that the sine of y is equal to 24 over 25. Okay, so that question, really need to think through how you could do it. No calculator, so you have to go through the process. Just leave it there for a few seconds, guys, so that you may hold it and kind of look through the process. Okay, so the next question talks about a right angle triangle. It's told us things about lengths and angles in a right angle triangle, so it's going to be trigonometry. So So we go through the process of labelling. Well, there's our angle, so this will be the opposite side, this will be our adjacent side next to it, and the longest side, the hypotenuse. And we go through the process that they want x, so that means we need to use the letter O out of SOHCAHTOA, so we definitely need to use those two. So car's gone because we can't use that, but we do know what H is, so again we can tick under H, but we don't know anything about A, so it must be the sine function. So we go through the process of writing the sine rule down, the sine function rule. So we've got sine theta is the opposite length over the hypotenuse, just follow the letters and put them on top of each other. So the opposite length we've been told we don't know, so we're calling it x, and the hypotenuse we've been told is 5.1. So we know the angle, so we've got the sine of 48 degrees is equal to our x divided by 5.1. We want to make x the subject, so that means move the 5.1 to the other side of the equals. So we do the opposite thing, so it's divide by 5.1, so the other side is going to be times by 5.1. So 5.1 times the sine of 48 degrees equals the x value. So again, make sure I calculate it in degrees mode. So make sure it's got a deg there. So we're going to do 5.1 times the sine of 48 degrees equals, so to three significant figures, 3.79, but of course we should always write down all the figures on our calculator to start with, and then show the rounding, so 3.79. The next part of the question talks about working with a parallelogram. So it's asked us to think about the area, so there's the key bit of information. So the first thing we've got to recognise is this talks about a formula then, so area has formulas. So we say that the area of the parallelogram equals the base length times the perpendicular height. And it's really important we recognise this is talking about the perpendicular height, because that implies a right angle, the word perpendicular, so we need a right angled length to the base length. So the base length is 6.8, and the question is really shouting out at us, find the perpendicular height. Well, what we recognise with this question is, hopefully quite quickly, that the perpendicular height is the same here, and what we should realise is this triangle is actually the same as the triangle above. And because we've already worked out what the length of x is, then this question is saying to us that this length h is the same as the previous answer. So h is equal to 3.79. If we hadn't been given that information, then of course we'd have had to go through the process of adding this on. So we now know that the area is going to equal to the base length, 6.8, times the perpendicular height, which was 3.79. So we put that in our calculator, so 6.8 times 3.79 equals, so 25.772, but again we can't really create an accuracy that wasn't there in the original numbers, so 25.7 is the sensible answer to write, so 25.7 square centimetres. Now question 8 is looking at a 3D figure, and it's asking us to calculate the length, the angle of DFH. So we follow the letters around, so D to F to H. So D to F to H. So add the information onto the picture. So go through the process of what do we know. So we know then that we've got a right angle triangle, and my advice always is to do a sketch of what the triangle looks like so we can see the information in 2D. And it wants the angle DFH, so we're after this angle here. So that's going to be our mystery angle, so we'll call it theta. And it's telling us then that we're dealing with a right angle triangle, and it's got an angle involved, so therefore we need some lengths. So we need two lengths. So we've got to ask ourselves, do we know anything so far? Well, again, when we go through the process of recognising this as a cuboid, then we know that the length of BF is 5, and therefore the length of DH is also 5 centimetres. So we know we can get 5 centimetres there. We need the length of HF or DF. We can't get those directly, so we've got to look at the shape again. And if we do a bird's eye view, so if we're looking downwards, we can see that there's this triangle here, which again is a right angle triangle. So we can sketch that out, and that might have enough information to see what's going on. So this triangle is GHF. That involves HF, which will be quite nice because that will then give us the information we need for this length here. That will then give us a right angle triangle with two lengths, then we can find the angle. Do we know HG? Well, again, we look opposite, 5 centimetres there, so this must be 5 centimetres. So we know HG is 5 centimetres. Do we know GF? Well, coming along here, we can see it's 12 centimetres. So we now know enough information on this triangle, because it's a right angle triangle, to find this length. Right angle triangle with two lengths given to find a third, Pythagoras. So again, we should go through the process of writing out what Pythagoras is so that we can recognise how we're going to use it. So the length of a squared plus the length of b squared is equal to the length of c squared. So we go through the process then of identifying the a, the b and the c. So we've got 12 squared plus 5 squared equals c squared. So we've got 144 plus 25 equals c squared. So the length of c squared is equal to 169. So c is equal to the square root of 169 because we want c itself. The opposite square is square rooting. So we end up with 13 centimetres. So c is 13 centimetres. So we now know this length. So again, it's all about adding on information as we go through the process. So we know the length of this, we know this triangle. So we've got the right angle triangle here, we've got an angle involved, so we go through the process of SO, CAR, TOA. Because we want to find a missing angle, then we label up the triangle. There's the angle, so this is the opposite side, this is the adjacent side, and this is the hypotenuse. We know O and A, so we can go through the process of ticking off O and A. This is the only one that we've ticked twice, so therefore it's going to be a tangent function to find the missing angle here. So we write out what the tangent function is. So the tangent of the angle theta is equal to the opposite length divided by the adjacent length. We want theta, so make theta the subject. That means we've got to do the inverse of tangent, which is called tan to the minus 1, the inverse tan function. So we're going to have to do inverse tan of O over A. So we do an inverse tan of the two lengths we've calculated. Well, O was 5 and the A length was 13. So we get our calculator. Inverse tan is above the tan key, so second function 10 to the minus 1, bracket 5 divided by 13, close bracket, equals. So again, we always give our answers to a sensible degree of accuracy, so usual thing, write down all the numbers off your calculator first, so 21.03751103, and then on the answer line we would write out the answer to a sensible degree of accuracy. So three significant figures would be 21.0 degrees. Okay, cut the number there, 21.0 degrees. So just to remind you what went on there. We wanted the angle DFH, so we drew on the picture so we could find out where the angle was. So the angle we needed was here. And we drew out a separate 2D picture from within the 3D so that we can see better what's going on. We put on the known information, decided that there was something missing, so we needed some more information. So we added onto the picture another triangle, another right angle triangle, and that did have enough information to then use Pythagoras. And once we got the missing information on the original triangle, we then recognised it was a right angle triangle with two lengths, need an angle, so SOHCAHTOA, either the sine rule, either the sine function or cosine function, tangent function would help us get the answer. And then we went through the process of working through how that worked. Okay guys, so that's a run through of trigonometry in 2D and 3D, mixed in with a bit of Pythagoras. Practice, this topic will come up. Might not be in 3D, but certainly there'll be something in either 2D or 3D with Pythagoras and trigonometry, popular at GCSE.